time, but that's okay. All right. So, do you guys remember what did we do in the last class?
Nope. Oh, we talked about exponents.
Exponents. Everybody's sure? So, we talked about exponents, where we talked about the 3 rules of exponents. Hello, Yaganya. Yaganya, can you hear me okay?
What do we learn today?
That is what I'll disclose. So hold your horses. Don't get excited.
Yeah, man, hold your horses.
Yeah, horses are going everywhere. Okay, guys. No, again. Make sure there's no parallel talk happening. There's only a talk between the teacher and the student.
Okay.
In the class, outside the class, I don't mind. Okay? So, Naita, okay? Yeah, okay. Alright. I know after a long day everybody would be tired, but I will try to make it as interesting as possible. So we talked about, in the last class we talked about exponents. We talked about exponents and we talked about the 3 rules of exponents. Is there anybody in the class who is still grappling to figure out what exactly are those exponents? Anybody? I don't mind teaching the same concept 20 times, but I mind if somebody doesn't understand it. Anahita, are you clear, beta? Yaganya, are you clear? Okay. Kian, any doubt? Hello, Adya. Okay. Adya, can you hear me okay, beta? Okay. You can keep your video on, beta, okay? Because I feel more comfortable dealing with you guys more like in-person kind of a thing. Okay? So, in the last class we talked about exponents. Adya, I think you missed the last class, right? On the Tuesday? Yeah.
I was distracted.
Okay. So, but my question to you is, if somebody misses a class, do you guys go back to watch the video of the class that you missed, or you missed watching the video? No, that sometimes it's not an optional thing, okay? I'm not a YouTuber where you're watching me for giving me views. I'm your teacher who is trying to teach you guys something. If anything is uploaded as a video of the class, even if you're 100% sure, spend 15 minutes, okay? At least do a recap, okay? After the class. Huh?
I do a recap,
By just what, I mean, wherever I'm giving the, wherever I'm preaching, that part you can skip. Only the math part you should watch to recap, okay? So Adya, I'm not going to repeat exponents today. I will let you just go through the video of the last class and then challenge me in the next class if there's something that is still bothering you. And be open, honest and brave to put this in front of me, okay? I'm not saying that whatever I explain, that goes like butter, okay? There could be something that I did not explain well. Always come back to me and say, okay, can you explain this one more time? That's okay. Yeah, Kian, you're saying something.
Oh, should I go to the, go get my water bottle?
100%. I will never say no for water.
Thanks.
So today we are going to talk about 3 basic things. GCF, prime factorization, and equivalent equation and expressions. So I'm curious to know who all knows what is a GCF. Describe.
Greatest common factor.
Okay, how do you describe it?
He's fun each almost every number has a factor, a number that can be multiplied to get to that number, and you want to find the greatest common factor, if you have 2 numbers.
Okay, let's see what Anahita wants to share. Yes, Anahita. You will have to literally shout at me, okay? Be a little louder.
Greatest common factors, for 6, it's 2, 3, and 1, and 6. I know. Yeah.
These are factors. These are factors. But I'm talking about greatest common factor, GCF. Kian, any idea?
I know what it is. It's when there's like two numbers. Well, I kind of remember, but it's been like a year. It's like when there's two numbers and you try to find their greatest common factor. Then you have to keep adding both the numbers by the same number until you get the same number eventually as the other one.
Okay. Swechha, have you come across this term GCF?
Yeah, the greatest common factor.
Okay. Okay.
Is this my pencil?
Anahita, hands down, beta. Now, I've heard you. It's okay. I mean, I'm not trying to prove anybody right or wrong. I'm just trying to get a sense of how comfortable you guys are when you come across this term. Okay? Adya.
So like the greatest common factor is like I don't know how to explain it, but I can use an example. So like let's say like a random number,
Okay.
and you like have to like list the factors that the numbers like this one number and another number can like make. I think I'm not that sure what the numbers that I'm saying about.
Okay.
And like trying to find out the number that they both the factor that they both have in common.
Yes. That is, see, greatest common factor. Let's keep the great thing aside. Common factor. That's how I'll break it down. Now, you guys must be thinking that this is a concept that probably we learned in 3rd, 4th or 5th grade. And why do we even have to talk about it? Because this is a very important element of entire algebra that we'll deal with. Be it simplifying linear equations, be it talking about factorizing a quality equation, whatnot. So this building block will help us sail through all those problems in a much easier way. That's why I'm trying to do a recap. Okay? So GCF, I'll not spend a lot of time on GCF, but we'll just quickly touch upon that and make sure that everybody is on the same page. So there are two parts to it. One is what do you mean by factor? Let's say if I'm talking about 6, I can break this into 2 into 3 or 1 into 6. These are the factors. We broke it down. Yeah. If I talk about 12, I can write this as 1 into 12, 2 into 6, 3 into 4. They are the factors. Now if I have to compare 6 and 12 and see what is the greatest common factor. What do you see common between these two? Okay. So here what do you see? Okay, let me see if I can. I will break this also 2 into 3. So there is one more concept I should first talk about, then I'll come back to this one. There is one more term or one more concept called prime factorization. Do you guys know what is prime factorization? What do you mean by that?
I do.
Okay, describe. Yeah. Okay, I'll come to you with that. Swechha is trying to say something.
How many common factors are in a, does a number have?
Prime factorization, okay. I'll come to you. Let me hear Kian. I'll come to you. Yeah, Kian.
So basically, it's when so there's something called like a factor tree. So it's basically when you list the factors, and if it's like
Don't
there's
move it.
a prime number, then like you can cross it out, and then you have to use exponents to like make an equation using that until you end off with a prime factor. Until you end with a prime number.
Okay, Anahita.
Can you say the question again?
What do you mean by prime factorization?
Prime factorization is like finding the prime numbers, and a prime number is like something that doesn't have like factors.
Yep.
Except
Okay.
one itself.
Okay. Adya, anything new that you want to add? Or you agree to what your friend said?
It's just I didn't really learn about prime factors yet.
Okay, we'll talk about it.
But
Yeah.
what I'm guessing could be like a factor that just has one in itself as a factor. I'm not really that sure.
Okay. Yaganya, any thoughts around that, beta? Oops, she got dropped off. So, everybody here, guys. On the board, all the time your eyes should be glued to the board. Okay? When we say prime factorization, we are talking about factorizing number, look at this. There is one thing that I keep telling to all the kids. If you have to figure out who is mother of math, any idea who that could be?
0.
Who is mother of math? Anybody? I mean, it's a theory that I have derived. I say it is English. So if you know English well, math you can derive. Now look at this one. I'm saying English is the mother of math. So if I'm trying to learn mathematical concept around prime factorization, I will go with the English first. Prime and factorization. These are two things. If I have a number, I have to factorize it in such a way that I only have prime numbers as factors. If I'm factorizing a number, if I'm breaking the number into smaller pieces, I'm breaking it in such a way that I have only prime numbers. Is that okay? So the mother is saying that factorize the number such a way that you have only prime numbers as your factors. Is that okay? Now let's look at 12. If I am trying to factorize it, how many ways I can factorize? 1 into 12, 2 into 6, 3 into 4. Now you look at the factors. These are the factors we got. 1 is a prime number. We all know what is a prime number, right? A number that can be divided by itself or 1. No, nothing else. Here, 1 is a prime number, but 12 is not a prime number, correct? 12 can be divided by multiple things. So here the factorization we have done, this is not a prime factorization. Look at this guy also. 2 is a prime number, 6 is not. So this is also not a prime factorization. 3 and 4, these are two factors. Here 3 is a prime number, 4 is not. So this is not prime factorization. Now, there is another way I can do it. I can write this part as 3 into 2 into 2. Now the factors I have, they are all prime numbers. Am I making sense to everybody, or I'm only teaching myself? Everybody okay?
I'm making sense.
Okay, that's good. So now we have factorized a number to the smallest possible numbers that every factor of it are prime numbers. That is what is called prime factorization. Now in this situation, if you could have done this one also, okay, 2 into 3, 2 into 3, 6, you can break it down like this. Now everything is a prime number. Now what you see is, you have 2 repeating, so you can put that as 2 square times 3. This is what Kian was hinting at. Correct, Kian? That's what you were saying? So when you factorize, you might come across a situation where you have some numbers being repeated, some small numbers. You put that in the exponent form. That's the whole thing. But in the simplest definition, if somebody says, I'm making Anahita sleep, no? Anahita is trying to stay awake. Okay, I know. So we'll keep it easy. So basically prime factorization, if you ever hear this term prime factorization, it's just saying, okay, you are factorizing it in such a way that you only get prime numbers as your factors. Is that okay? Everybody okay? Ayush, you keep forgetting about me.
Who's purple rose?
Purple rose is Ayush. Ayush has always been in the class, but today you have joined again 15-17 minutes later. This is not acceptable. I would recommend, request, whatever, to make sure that you join on time. Okay? Now, so we are talking about prime factorization, and again, when we do some problems, then you will understand it. And whatever you missed, you'll have to watch the video for that. I don't know how seriously you guys are watching video, but I have started mandating it now. It's a message request for parents also to remind the kids that they start watching the video. Otherwise, the whole purpose of making this video gets diluted, if not killed. Okay? Alright. Here, prime factorization. If I say, do prime factorization of 13, how much that would be?
No, you can't.
No, there is no answer is no, I will accept.
13 times.
No, it's just 1 and 13.
1 and 13, that's it.
1 and 13.
That's it. Don't say no.
I said 13 times 1.
This is your prime factorization.
I said 13 times 1.
Yeah, for your first response was no. You cannot factorize it. That's what I'm arguing about. Yeah? So any number that you have, there is no way you can say no for prime factorization. Okay? Is everybody okay so far? If I say do prime factorization of 40, what will that be?
20.
No.
Oh, no.
Get your hands dirty.
Okay.
Switch do it on the paper, beta. You have your notebook?
I can check my notebook, but I can also try doing it mentally.
No. Mentally it's perfectly fine because I'm old school guy. Huh?
I think I know. 5 times 2 times 2 times 2.
No, okay.
It's 2.
So I want to say it.
I did.
Yeah.
Right here.
So then what is the answer? That unless I see it, how would I believe it? Okay. Okay.
I got the answer.
Yep. Well, how much it is?
I got 2, like in exponential form.
Yeah, that's okay.
Okay, I got 2 to the power 3 times 5.
Okay. You same?
Yeah.
Okay. How about switcher? Yeah, same thing. And if you did not bring your notebook, you can borrow a page if that helps. Yeah. You have it? Okay, wonderful. That's a notebook lying there, right?
Yeah.
Yeah, you can use that one, no? That's fine. That's for the kids only. Yes, Yaganya.
I also got 2 to the power 3 times 5.
Wonderful. So it's very simple. 40, you will say, okay, 2 times 20. Okay, now 20, like what Vivan did. He created a tree structure. Okay, I have 40, 2 times 20. Okay, this can further split into 4 times 5. Okay, 5 is a prime number, but this can split into 2 into 2. So you have 2 times 4 times 5 times 2 times 2. So 3 2's, that will become 2 into 2 into 2 into 4 into 5.
Wait, how is it 4?
That's right, my bad. Yeah, my bad. So 2 to the power cube, 2 to the power 3 times 5. This is a prime factorization. Anahita, what did you get? Same?
No, for the 20, I added 10 times 2.
But that is not a prime factorization yet because 10 is not a prime number yet. So you have to keep on breaking it.
That's what I did, and it just said to keep on breaking it.
Yeah. So you have to keep on breaking it till you come to a point that all your numbers that you have, they are all prime number by itself. Yeah?
Oh.
Yeah? Now, the $1 million question is, why are we doing all this? This is something that a kid younger than you guys will do. Okay? Because we are going to talk about equivalent equation and equivalent expression.
Oh.
And this is the building block for that. If you are not clear about this, if you don't know what is GCF, what is prime factorization, you are coming across a situation called deadlock. Okay? So that is why all these things, if a guy with all grey hairs can do, you guys have a long way to go. You must do. Okay? So now, before I jump on to equivalent equation and equivalent expression and equation, let's come back to GCF. Greatest common factor. Ayush, Yaganya, Adya, Anahita, Kian, Swechha, Bhivan and Ashrita. Everybody okay? I'm not going fast. I'm not making you guys rush. Because I want you guys to cherish each and every math that we do. Okay? And you have to literally be emotional about it. Enjoy the math that you do. Okay? The day you don't enjoy, let me know. We can take a break. Okay? Now, what is GCF? GCF is greatest common factor. And you will not do GCF. Say, okay, I have a number 25. I'll do a GCF for that. No, you cannot do. You talk about common. If I ever say, what is common between me?
You can't do it.
What is that I'm comparing with? When you're saying common, you have something to compare. Then only you are saying common.
You have to have multiple things.
If I say, what is common between me and Vivan, you'll say only glasses. Yeah?
Very smart.
I'm not.
Oh.
That's the problem. Anyways, come in here.
That's it.
Come back here. We will have a lot of interesting things to talk about after the class. So GCF, greatest common factor. This common comes into play when you have more than one thing to compare. Now if I have 15 and 25, somebody says find out the greatest common factor.
5.
5. 5.
Yeah.
Ayush, how much? What is the greatest common factor here between 15 and 25? Yes, Adya, tell me.
I got 5.
You also got 5. Everybody got 5.
I got 5.
Okay. Now, I did not get anything because I did not do anything. So let me get that first. I will use this tree method like what Divan was doing.
Oh, okay.
I have 5 and 3 as my factors here. Both are prime numbers.
Yeah.
I start here. In this case, 5 into 5. Both are prime numbers. I stopped here.
Yeah.
Between these two things, now go back to English. Greatest common factor. Let's first find out what is the common factor.
5.
5 and 5.
Yep.
And that is the only thing that is common between these two. That is the GCF. Yeah.
And it's also because it's also the biggest one.
Unfortunately, that's the only one. Be biggest, smallest. What to do? Yeah. So this gives us how do you find the GCF. Tomorrow, if somebody says, oops, find out the GCF of our greatest common factor of 30, 16 and 24. Same thing, I'll probably try saving some time for you guys. 2 into 15, this 15 becomes 5 into 3. So I have only 3 factors. All the ones at the bottom. That is these are my factors here. 16 gives me 2 into 8. 8 becomes 4 into 2. 4 becomes 2 into 2. Yeah, now all are prime numbers. So this one, this one, this one, this one. Okay. 24 gives me 2 into 12. 12 becomes 3 into 4. 4 becomes 2 into 2. Yeah. So my factors are 2, 3, 2, 2. Now between these 3 numbers, what is the GCF here? Yeah.
3.
3.
Because it's
Sure. No,
yeah.
don't rush. Don't rush. Get in the habit of reviewing your work.
Can I?
Yep.
Like 3 doesn't become 16 and then root.
What is that?
Root.
What is your answer? Just give your answer.
Mine?
Uh-huh.
Mine is, I didn't say yet. Mine was 2.
Okay, Adya?
I got 2 because like out of all of them I compared.
Okay.
All of the numbers are divisible by 2
2.
because they're all even. You know
So,
what I mean?
so I'm not even going there, okay? I'm not even caring about all those calculations. I'm just looking at my tree. And from this tree, I will look at all the circles and see which all circles are common, okay? Yes, Anaita. How much did you get?
I think it's 2 because all of them have
2 common?
only one common factor.
Okay, Asita.
I think it's also 2.
2. Everybody thinks 2.
Yeah.
How about Ayush? 2. Kian 2. Swetcha 2. So here's the thing. Do it in the lamest possible way you can think of. If you guys are with me, I will not talk anything fancy. I will talk all silly, stupid stuff. Because that's what stays with us longer. All the bad things we learn, that carries much longer time, right? So let's look at the stupid things here. Look at this. This 2, 2 and 2 is common. Now you have mark 2. Is there any other number that is common? 3 is here, 3 is here, but not here. 2 is here, but there is no other 2. So only 1, 2 is common. So 2 is your greatest common factor. Now comes the point that why this is important for us. This tree structure that we are drawing to derive the GCF is going to be very handy for us. Now let's look at it. If I say that you have an equation 12x minus 15y equal to 18.
Oh wow.
Simplify this equation. Time to cry? Don't cry over the spilled milk. No, there's no milk
This is
spilled.
not possible. I know the answer. This isn't possible. Actually, I don't think it's possible.
There's nothing possible. I'm just saying simplify this. You can always simplify this.
Impossible.
6 times 3.
Yes, Kian.
6 times 3.
6 times 3 what?
What?
Simplified.
Okay, no, I heard you. Let's see what Anahita says.
I don't know how to do it.
I'm saying simplify this, okay? If, let's say, yeah.
4x minus 5y equals 18.
Equals 18. Are you guys serious?
So I don't have to figure it out, right?
I'm sorry?
I don't have to figure it out, right?
It's okay, but see, I have put a question in front of you guys. So far, I was blabbering about GCF, prime factorization, all those things, right? Now, I'm trying to connect the dots.
Wait.
Why is that needed?
Rocking.
You were going the right direction and then you missed the track.
Okay, so is it 4x minus 5y equals 6?
That is what I was waiting for. Yeah. So the answer that I got from Vivaan is 4x minus 5y equal to 6. And here's the
I simplified all of them by 3.
Here's the thing, I don't care about the answer. That's the problem. Because I want to see why, how he got it. Now if you look at it, 12x minus 15y equal to 18. What we can do is, let's do prime factorization of all of them. 2 into 3, this many x. 15, so let me not jump here. 12, I can make it 2 times 6, it becomes 2 times 3. Okay, so 2, 2 and 3, these are my prime factorization here. Let's do 2 into 3. Similarly, 15, I can do 3 times 5 and that's it. So 3 into 5y equal to 18 becomes 3 times 6 becomes, so 3 into 2 into 3, that's my prime factorization here. 3 into 2 into 3. Now if you look at these 3 terms independently, what is your prime factor, what is your GCF among the 3? What is common in these 3 terms?
3.
That's what. So you see that this one and this one has 3 common. So if you just look at these 3 terms independently, 3 is your GCF. That means you can divide all of them by 3. So this 3 and this 3 tic-tac-toe, this 3 and this 3 tic-tac-toe, and this 3 and this 3 tic-tac-toe. What do you have now? 2 into 2x, that is 2 into 4x, minus 5y, equal to 3 into 2, 6. Yeah? So this is what I meant by simplifying it. Yes, Anahita, let me get your question first.
Can we just divide it off of 3?
Yeah, you can. So, see again, we will come to that one, okay? We will come to that one. What is equivalent equation, what is equivalent fraction, expression and all that thing. But what I was trying to show you guys here was that GCF that we are learning, that I was forcing you guys to recall, was the source for us to simplify this equation, this little monstrous equation to this cute equation. Yeah? Yeah? It's okay. So I don't care about the answer, that's I keep insisting on. Because my focus is always on making sure that what we're doing, there's a method to the madness. Here, everybody here. There's a method to the madness. Okay? That's what I call as process. And if that process is clear, we can do magic. Let me take a pause here first. Ayush, Yaganya, Adya, Anahita and Kian. Is everybody with me so far?
Yeah.
Anahita's yes was very cold. I'm not sure it was confident or not, but I hope we are making sense so far, yeah? So what I was showing you guys, so here, Swechha, Ashrita, and Vivan, everybody okay? What we are trying to convince ourselves is why that GCF or prime factorization is important, because that helps us, that concept we can use for simplifying equations also. Okay, so when we deal with system of equations, quadratic equations and all that thing, we will use these concepts for breaking it down to simplify it and to get to a solution. Okay, if I am using some buzzwords to get you guys scared, system of equation, quadratic equation, don't get scared, it's okay. We'll again keep breaking it down to simpler things to understand it better. Is everybody okay? Ready for the next ride? Okay, wonderful. What happened? Let me give you guys 30 seconds to unwind and get ready for the next thing. Everybody okay? I know you guys had a long day after school, it's a little stressful, but everybody okay? Switcha okay? You look tired, all okay? I'm sorry?
I have 3 projects that I do today that I'm not going to.
I have 3 recent assignments.
I feel very happy about it. Because when I was your age, I had the same level of stress. Okay? Ask uncle how much of stress and competition we had during our times. Okay? Yes, Adya.
I finally get some rest. Yay.
What did you get?
Rest.
Okay, yeah. Okay, no, so I was, see again, for me also to change gear from one thing to another thing, we have to do switching, okay? If I just continue in the same flow, I will not be able to articulate well and I'll get you guys confused as well. Now we are going to talk about a concept called equivalent equations and expressions. What does it mean actually? What do you mean by equivalent? Then why do we need one extra word? That is difficult for somebody who is not from English medium like you guys. Why do we need 2 words? I had a hard time learning English, trust me.
Equal equations.
Okay. Anahita, tell me, what do you mean by equivalent equation? Somebody is saying equal and I'm contesting that. Why do we need to call equal as equivalent?
It's basically 2 equations that have the same value.
Okay.
It's maybe like, can I get an example?
I'll come to that. So I'm just picking everybody's brain right now. Yeah, yes, Swechha. Tell me about that.
Maybe it's not equal because, like, for example, when you simplify 15 over 3, it simplifies to like 5 over 1, but it's not equal because you have to like simplify it.
Okay. Alright, our last time. And then, okay, we'll stop there, okay? Let's not muddle the water much. Yes, Anahita, one last time.
In fourth grade last year we learned the system of fractions, so maybe it's like the same thing but just the equation.
Something similar may or may not be equal. That is what is equivalent. Okay? I'm again going by English, okay? And even if I keep saying that English has never been my first language. I never learned things in English. I learned everything in my mother tongue and then gradually moved to English, okay? So you can understand how much of transition I've gone through to be able to talk to you guys. Coming back to this one. When I say equivalent, are you with me so far? Are you able to follow me?
Yes.
So you have to keep on waking me up, I'll keep waking you up. Okay, that's the deal.
Okay.
Okay. You will wake me up only when you see me sleeping, okay? Alright. Yaganya, can you hear me okay, beta? Okay. Alright. So we were talking about what is the difference between equivalent and equal. Equal is equal, copy paste, exact value, matching, no doubt, no confusion. Hold your horses. No. So when we are talking about equivalent, it's the difference between same and similar, right? Similar is somewhat matching, but not exactly matching. So is the case with equivalent. Now let's look at it. If I say 5x plus 20y equal to 30. 5 minutes ago, you guys helped me simplify this. Okay? I can, let's do that. Let's factorize it. It becomes 5 into x. This becomes 5 into 2, 5 into 4, this becomes 2 into 2. So this becomes 5 into 2 into 2. 5 into 2 into 2 y equal to 30 becomes 5 into 6, 6 becomes 2 into 3. So this is 2 into 3 into 5. So 2 into 2 into 3 into 5. Now we are doing GCF. Finding what is common among all of them. This one, and this one is common in all the three. Nothing else. So we'll divide everything by 5 and see what happens.
X plus 4.
So 5 gone, 5 gone, 5 gone. See, there's a amount of happiness that I achieve or cherish when I'm doing this, okay? So that's why I'm not in a hurry to, see when I'm cutting it, I'm actually enjoying that exercise. So that's why I'm not in a hurry to tell, okay, this will be X. No, I'm not saying that. I'm doing it so that I don't miss on the opportunity to enjoy it. 4 times y, 2 times 3 equal to 6. See this equation and this equation that you see. This equation came from this one. This equation is equivalent to this guy.
Oh.
Is this same like this? No. Am I making sense? Ayush, Yaganya, Adya, everybody with me? Kian. This is called equivalent equation. So whatever this guy can do, this guy can also do. But do they look alike? No, they don't.
Nope.
Anahita, am I making sense, beta?
It was an accident.
I'm sorry, beta?
It was an accident.
It was?
Accident. An accident.
Excellent or accident?
Accident.
Oh, okay. No, I was just checking that whatever I'm doing, you guys are with me so far. Ayush and Yaganya, are you guys with me?
Yes.
Yaganya, can you hear me okay, beta? Yaganya is angry with me. Okay. How about Kian? Are you okay? Okay, good.
Yes.
Okay. So basically, now if you connect the dots, we talked about GCF, we talked about prime factorization, we applied that to simplify an equation, and now I'm saying this is where my equation, this equation is equivalent to this equation. Whatever this guy can do, this guy can also do, but this is a much cuter application compared to this guy. Yeah? If I have to deal with this kind of equation, I'll be more comfortable than dealing with something which looks little more, loaded or deep in your words. Yeah? Alright? Which one is looking deep? This one or this one?
First one.
First one looking deep. So these are some of the terminologies that I keep learning from my daughters. This one is not deep, this one is deep.
Oh, I see what you mean.
You know what I mean? Okay, cool.
I still understand, but then I understand.
Okay.
You never understood.
Alright guys.
It's not that deep.
Back to the class.
Ooh, I'm a smart aleck.
Yeah, I think.
Okay. Alright. Don't get carried away by my jokes, okay? Okay, coming back to this one. So we saw what is the use of GCF. Even if you guys were on the verge of forgetting it because this was an old story, now I'm making those concepts back because we will be using that extensively in the things that we do hereafter. And we saw how we can use GCF and prime factorization for simplifying an equation, and that's what we are calling as equivalent equation. Yeah? Same thing. If I have an expression, let's say, What is an expression in the first place? Who all knows what is an expression?
An expression is an equation without an equal to sign. Like it doesn't equal to anything.
Okay. Anybody else who can define? I heard one good definition of expression, but anybody else who wants to add to it? What is an expression?
It's like an equation but without the answer.
Without the equal to sign. Now I'll give you guys an example. You will never forget. Now, if I have an equation x plus 2y equal to 15, there's an equal to sign. That's why we call it equation. There's an outcome. There's an outcome. By doing something, you get an outcome. This is the result. If you don't have this equal to sign, there's no result. Okay? That is called expression. It is analogous to what I'm doing now. Okay, here. If I come to the class, I keep smiling, make different faces. So my expression to you guys. Hold it. So my expression to you guys, don't teach you guys anything. Expression, no outcome. It's only waste of time. If I stop smiling, stop laughing, cracking jokes, and I'm doing something, there's an outcome. That is an equation. So that's the difference between expression and equation. Expression has no outcome. It's as good as your teacher giving expression, you are doing anything. Equation has an outcome. That's the main difference. Okay? And if you have an expression like this versus this versus this, what is the difference between this and this?
The first one's more simple. It gets more harder.
It gets harder as you look.
Okay, something more. Yeah. Add it. I'm
More complex, like there are cubes, and then you're.
So you said the same thing, so you're not adding value. Let me hear everybody else. Yes, Swecha, go ahead. Anahita, Kian, I want you guys to think about these three and tell me what is the difference you are seeing. I got one point of view which says this one is easier, harder, even harder. But I want to hear more. All these three are expressions because there is no equal to sign. So all of them are expressions. Yes.
There are like more variables.
More variables. Okay.
Yeah, I was gonna say that, but also only two of them come together wash.
Okay. What else? Okay. Now I need everybody's 10 minutes because I have a speech prepared for today's class and I want everybody to hear that out. Oh my God. Now, every expression that we talk about, it's not a speech, I was joking, okay? If we talk about any expression, this guy and this guy, what do you see? There is a plus sign in between. Here, there is only one plus sign. When you look at this guy, there are two plus signs. Let me change this plus to a minus. Okay? So the plus and minus signs are the separators. When they are, say, okay, this guy is separating this and this, okay? So these separators decide how many things are there. Here you have two things, this one and this one. These two are two things, which is separated by this plus sign. Two things, I will not call it two things, I will call them two terms. So this expression has two terms, this one and this one. This expression, if you see, one term, two term, three term. I am not looking at multiplication thing, okay? I am only looking at the plus and minus sign is separated. That is helping me count the number of terms we have in the expression. Here you have 1, 2, 3 terms. If you look at this guy, 1 term, 2 term, 3 term, 4 term. 4 terms. Based on the number of terms you have, there are names for those expressions. If I had only x cube, meaning no plus sign, this is only one term. This is called monomial expression. Here you have two terms. This is called binomial expression. Here you have three terms, trinomial expression. Here you have more terms. So anything that is one, that is monomial. More than one, polynomial. You will be haunted by this term hereafter, so much so that this will become a part of your math journey. So when you have an expression, what I'm trying to say here is, when you have an expression, your plus and minus sign are the separators that helps you determine how many terms you have. Everything that is separated by the plus or minus sign is called a term. This is one term, other term, one term, two terms, three terms, 1, 2, 3, 4 terms. So depending on the number of terms you have in an expression, they are given different names. One is monomial, more than one is polynomial. You can be very specific here. One term monomial, binomial, trinomial, quadrinomial, pentanomial, hexanomial, heptanomial, octanomial, whatever. But why you have to stress out so much? Just two varieties, monomial, polynomial, that's it.
Wow. Very cool.
Did I get people stressed out?
Yes.
Okay, so don't worry about it. My job was to get you guys confused and then clear the rest. Okay. See, as soon as you said confused, the teacher disappeared. I'm back, don't worry.
Wait, what? The teacher disappeared yesterday.
So let's start from the beginning. Ayush, Adya, Anahita, are you guys with me so far?
Yes.
Yaganya? Yaganya has been very quiet today. Is it because of network or is it because of me? Okay. So, let's start from the beginning. We talked about what is equation and what is expression. Is that clear to everybody? Equation is something that has an equal to sign or that has an outcome. Expression is something that doesn't have an outcome or doesn't have an equal to sign. No doubt? Now, when I have an expression, that means I have something without an equal to sign. Yeah? This is also an expression. Yeah? Everybody okay with me? Now, I have this minus 6x. This is also an expression because this guy doesn't have equal to sign. This is also an expression because this guy also doesn't have an equal to sign. Yep. So this is expression, this is also expression. But there is a difference between this guy and this guy. Here you are dealing with only one term. Here you are dealing with two terms. Because they are separated by a minus sign. Okay? So when you have only one term in your expression, that is called monomial expression. Monorail, a rail running with only one track.
That's what mono is.
Yeah. So monomial is an expression which has only one term. When you have more than one term, that is polynomial. There are specific names, very specific names. 2 terms binomial, 3 terms trinomial, 4 terms quadrinomial. But I'm just flexing here right now. Okay, I'm just flexing here by giving all those names. Polynomial. No, there's no polyrail. Okay, let's not worry about it. Imagine how difficult it will be for engineers to design a rail which has 5 tracks.
They probably do.
Okay, so anyway, that's out of the syllabus. Let's come here. Let's not worry about the design problems for mechanical engineers. Let's come back here. So this expression has only one term, that is monomial. More than one term, polynomial. Now, whether I have 2 terms or I have 3 terms, whether I have 4 terms, 5 terms, anything more than one is many, right? More than one is many, correct? One is one, more than one is many. Many is poly. So this is monomial, polynomial. Okay? And if you guys want to flex like the way I was flexing a few minutes ago, binomial, trinomial, quadrinomial, pentanomial, hexanomial, All those are interesting words.
Wow.
Remember it, enjoy it. If you don't remember it, there's nothing that you're losing. Alright? Okay, so here we talked about what is expression, what is the difference between monomial and polynomial expressions, and the only thing to remember is your separators, which help you count how many terms you have, is either minus or a plus sign. That's it. Okay? So now, is this part clear to you guys, or I'm still getting you guys confused? Clear?
Yep.
Everybody? Swechha, Anahita, Kian, Adya, Ayush and Yaganya. Okay. Then you have an extra task of watching this video one more time. Okay? Last 10 minutes of the video when I upload, just watch it. Okay? Sometimes what happens is, when you're just listening to me and not doing your scratch work, it might be difficult to relate. But when you are watching it yourself, pause the video, then write it yourself, you will see that something that was not clear gets cleared up. Okay? And if that is still not working, I'm not going anywhere. My address is not changing. Okay? Don't worry. Alright? So, now this one important thing that you guys want to be aware of. This is a very simple, easy stuff, but no, we kind of overlook that. Okay? Now let's look at it. What are you looking at right now? Is it a monomial expression or a polynomial expression? Don't rush. Don't rush. Think about it. I'll give you guys 30 seconds.
Think about what?
What is that? I think it's
Okay.
I know what it is.
Everybody here. The simple question to you guys is, and there's a prize for this. The prize is $1 million to the power 0.
It's $1.
So when are you gonna give us these $1?
That's what. Okay. Okay, but let's not worry about the prize. I'm making you guys realize that this is what we learn in the exponents and we are applying it in real life. So coming back to this one, is this a monomial or polynomial?
Polynomial.
Okay. Anahita.
Which one's polynomial is 3 or 2?
No, I'm asking this one. Is this a polynomial or monomial?
I think it's polynomial.
Polynomial? What do you think, Swechha?
Yeah, I agree with.
You think polynomial?
Yeah.
His name is Vivan. And he's saying polynomial. And I'm super happy to say that everybody is wrong.
It's monomial?
It's monomial. Because what did I say? How do you count the number of terms is defined by how many plus or minus signs you have. Did we have any plus or minus sign here?
No.
We are looking at only one term. So that is why I was saying that always remember the application part of it. Don't miss the minutest detail that we talk about. So again, no offense here. What I'm saying is, this by the outlook it will give you that feeling that there's so many variables. Even if you have 4 variables to deal with, this poor guy is a monomial. How difficult it will be to solve it or deal with it, that's a different thing. But by definition, it's a monomial. Making sense? Kian, Adya, Yaganya, Mr. Purple Rose, or Ayush, Anahita, everybody okay? Yeah? Yeah, Anahita, tell me.
I already took the reaction button.
That's okay. But I hope I'm making enough sense to you guys and you got the main construct of what is an expression. How do you difference between expression? How do you make your decision to determine which one is polynomial or monomial? Because polynomial is going to be part of our life till 11th grade. So if we get these concepts now in the simplest form, it'll be easy to apply them when you guys grow up a little bit more. Yeah? Is everybody okay or super exhausted with my speech? Exhausted? I'll let you guys go and enjoy the rest of the evening. We'll talk again in the next class. Alright?